Imagine holding the iPhone 17 in your hand, a phone so precisely engineered that even a microscopic mistake could cause total failure. What you're holding didn't come from a single factory, it didn't come from a single country, and it certainly wasn't built overnight. The iPhone 17 is the result of one of the most complex, efficient, and tightly controlled manufacturing systems ever created by humans. We go inside the smartphone factory to uncover how millions of iPhone 17 units are built every single day through machines, robotics, and human precision working together in perfect synchronization. This is not just how a phone is made. This is how modern industry operates at its absolute peak.
Everything begins inside high-security industrial intake facilities. Massive trucks arrive carrying refined aluminum alloys, lithium compounds, rare earth elements, and ultra-pure silicon materials. Forklifts move in synchronized patterns, conveyor belts activate instantly, and automated scanners log every shipment into the system. Workers in protective gear inspect materials under bright industrial lighting. Even a tiny impurity can ruin thousands of devices, so nothing is left to chance. This is not storage, this is precision preparation.
Before production begins, raw materials enter laboratory zones. Here, chemical composition is analyzed, metal density is measured, impurity levels are verified. Technicians operate diagnostic machines with controlled movements, while robotic arms transfer samples into testing chambers. Only materials that meet strict standards are approved for production, and everything else is rejected immediately. Efficiency here saves millions later.
Now, we enter one of the most advanced environments on Earth, the semiconductor fabrication zone. Inside ultra-clean rooms, silicon wafers move silently across automated tracks. Machines etch billions of microscopic transistors onto each wafer, a process that operates at a scale invisible to the human eye. The processor that powers the iPhone 17 is created layer by layer using extreme precision, heat control, and photolithography. Workers move slowly and deliberately, not because production is slow, but because perfection demands discipline. A single defect means total rejection.
While processors are being formed, another factory focuses on what users notice first: the display. Ultra-thin glass sheets glide along illuminated conveyor belts, while robotic systems deposit organic layers with atomic accuracy. Every iPhone 17 screen must look identical, flawless and responsive.
Inside another controlled facility, camera components come together. Lens elements are aligned using robotic arms capable of micro adjustments, and image sensors are tested under electronic imaging systems. Technicians monitor calibration screens, ensuring accuracy before assembly continues. The camera is not just hardware, it is precision engineering combined with software intelligence.
Battery cells enter temperature-controlled production lines. Each battery is molded, insulated, and sealed, and charging cycles begin immediately, testing durability, heat tolerance, and stability. Memory chips are stress-tested under extreme workloads with speed, efficiency, and reliability verified. Only components that pass every test move forward. Now, the physical identity of the iPhone 17 begins to appear. Solid metal blocks enter CNC machining lines, and cutting tools carve frames with extreme accuracy. Edges are polished, surfaces are refined, and colors created through controlled anodizing. Not paint, but chemistry. Every frame is inspected both by machines and human eyes. Now, the physical identity of the iPhone 17 begins to appear. Solid metal blocks enter CNC machining lines,
and cutting tools carve frames with extreme accuracy. Edges are polished, surfaces are refined, and colors created through controlled anodizing. Not paint, but chemistry. Every frame is inspected both by machines and human eyes. This is where everything comes together. Assembly lines stretch across massive factory halls, and conveyor belts move at constant speed. Robots install processors, workers place batteries, and displays are aligned and sealed. Every movement is timed, and every station performs a single task flawlessly. Engineers oversee operations, while automated systems track every unit. This is industrial choreography at its finest. Before packaging, each iPhone 17 enters final testing. Screens are calibrated, cameras are checked, and connectivity systems are verified. Devices undergo heat tests, vibration tests, and performance simulations. Any phone that fails is removed instantly. Only perfection is allowed to continue. Approved devices move into automated packaging lines. Phones are placed into precisely designed boxes. Accessories are added, and boxes are sealed and labeled. QR codes and serial numbers are logged into global databases. From here, the iPhone 17 begins its journey across the world, to warehouses, stores, and finally, to you. The iPhone 17 is not just a smartphone. It represents a global industrial ecosystem. Millions of workers, hundreds of factories, and billions in infrastructure. Every unit reflects human coordination at scale. The next time you hold an iPhone 17, remember this. You are not just holding a phone, you are holding the result of global precision, discipline, and engineering mastery. A product shaped by machines, perfected by humans, and delivered through one of the most efficient manufacturing systems ever created. This is the hidden world behind your smartphone.
Look at the phase shift on channel 3.
It's adapting to the amber light perfectly.
Look at the alignment tolerance here. It's slightly off spec.
We should recalibrate the arm before the next sequence starts.
The graphs are fluctuating slightly as they rotate.
It seems to be stabilizing now that the conveyor is active.
We're green across the board. The thermal output is nominal.
Good. Let's pull the data logs now.
State, Bacho Bichu Nai Utri Bantinga Nike Ha. Jisam Devi Nipul Chene, Kozarrington 18th century.